All right, so now we're going to go a little further with systems. And I'm now on page, I think it's page 3, it says right down here of my notes, lesson 6.1. Now that we kind of know what a system is, we know that the point where they cross is the solution to the system. We are going to actually, a little more introduction, we're actually going to determine if it's a solution to the system or not. So it says, a solution to a system of linear equation in two variables is an ordered pair. That's just fancy for, a point like 7, 3. And it satisfies both equations in the system. So that's kind of what we're dealing with now. So here we go. It says determine if the ordered pair is a solution to the system. So here is our actual system. And we want to know right here for A, is 3, -4 a solution? So you guys know that this, of course, is X and this is Y. So we're going to take both equations. I'm going to write one here, 2x minus y equals 10. I'm going to write the next one right next to it. So x plus 3y equals -9. And we're going to do some plugging and chugging. We're going to put in the x and the y, and then we're going to solve, and we're going to see if one side equals another. We did this when we were just doing linear equations, and we wanted to know if it was a solution to the equation. So we just did it for one line, and now we're going to do it for two. So it's really kind of the same thing coming back to you. So where x is, I'm going to put in 3. So there's x right here. So I'm going to put in a 3. So it'd be 2 times 3 because they're mushed together, minus y, which is -4. Be careful. And then equals 10. So now I'm going to do the math. 2 times 3 is 6. Minus a negative, which makes it positive. So minus, that'd make it positive, equals 10. And 6 plus 4, 10 equals 10. So far, so good. Yes, it works in that equation. So now it says it's got to satisfy both, so I have to plug it into the next one. So it says x. Where x is I'm going to replace it with 3, just like I did on the other one. So 3 plus 3. Now where y is, I'm going to put in a -4, and then equals -9. So just going to plug it in like I did before. So 3 and then 4, -4 times 3 is -12 equals 9. 3 minus 12 is -9. And -9, and oops, I forgot that negative. Bring down the -9. -9 equals -9, and yes, it works. Because this works in both equations, here and here, yes, it is a solution. It works. Yay, yay. Okay, so now we're going to do the same thing for this one. So we have our two equations, and they want to know if this is a solution, 0, -5. So x and y. So I'm going to take those two equations. I'm going to rewrite them. I think I'm going to just draw a little line here so you know I got one and the other. So 2x minus y equals 10. X plus 3y equals -9. I'm going to plug in 0 for x and -5 for y. So I'm going to have 2 times 0, because that's x, minus, and then I've got y, which is -5, equals 10. And I'm going to solve. So I've got 2 times 0, which is 0, minus and minus, which make it a +5, equals 10. And 5 equal 10? It doesn't. So I'm going to put a line through my equal sign because it doesn't equal, and I'm going to write no underneath. Now, once one of them's no, you usually don't have to do the other one. We're going to do the other one just to show. So it asks for x, so that's 0, plus 3 times y. Y is -5, and that equals -9. So 0, and then 3 times -5 is -15 equals -9. -15 equal -9? It certainly does not, so that is also another no. So is this point a solution to the system? No, it is not a solution. Now, what does that mean? Remember, if you remember from our notes before, A solution is where the lines cross or the lines intersect. So this means these two lines, if I were to graph them, cross at this point. So, oops, I kind of was messy with my circle. So they cross at 3, -4. That's where those lines cross on the grid. They do not cross at here because it's not a solution. So that's what we're talking about. Is it a solution or is it not a solution? So we can move on to the next page, same type of thing. So determine if the ordered pair is a solution or not. So we'll do one more. So here's 2, 4. So x and y. I'm going to take my two equations. So y equals 2x. And then 3y plus x equals 14. So I'm going to plug in x and y. So I'm going to plug in 4 for y equals 2. And then I'm going to plug in 2 for x. So 4 equals 2 times 4, which is 4. So far, so good. That's a yes. So now let's do the next one. So 3 times y, which is 4, plus x, which is 2, equals 14. Whoops. Sorry for the jumping. 3 times 4 is 12. 12 plus 2 equals 14. 12 plus 2 is 14, and 14 equals 14, so this is also a yes. So yes, it is a solution. Now we can test out, so that means at this point is where these two lines cross. They cross at 2, 4. Next, same thing. Let me put a line here so we know y equals 2x, and then 3y plus x equals 14. So now I'm going to test out 0, 0. That's an easy one to test. I like when we have that. So it's 0 equals 2 times 0. So 0 equals 0. So that's a yes. So let's do the next one. So 3 times y, which is 0, plus x, which is 0, equals 14. So 3 times 0 is 0. 0 plus 0 equals 14. 0 plus 0 is 0. Does that equal 14? No. And because one of them is a no, it's got to work for both. So this is no, it is not a solution. So that means those two lines do not cross at 0, 0. They do not cross at 0, 0. There's a couple of more examples for you to try on your own. A system is a set of equations. Usually 2 or more. And what does a solution to a system represent? The point where they intersect or they cross. All right, there you have it, ladies and gentlemen. Testing solutions to systems. Good luck.